Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gil Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gil@eapen.info. Guest today is Professor Azra Raza, who is a professor of medicine and director of the MDS Center at Columbia University. She's a practicing oncologist, seeing 30 to 40 cancer patients weekly. She worked with President Clinton designing breakthrough developments in science and technology, and with Vice President Joe Biden for the Cancer Moonshot initiative. Her latest book, The First Cell and the Human Cost of Pursuing Cancer to the Last, was published in October 2019. Welcome, Azra.
Thank you, Gil. Honored to be here.
Yeah, so I want to start with an article that you wrote recently, and it's entitled "Cancer is Still Beating Us. We Need a New Start." Most patients, in which you say most patients continue to face excruciating, costly, and ineffective treatments. It's time to shift our focus from fighting the disease in its last stages to finding the very first cells. This is also the theme of your book. Before we get into it, could you provide an overall view of where we are in terms of treating cancer, incidence rates, survival rates, and extension of life through treatment and so on?
Yes, sure, Gil. Thank you for a very good start to this conversation, because let's begin with some statistics.
Yeah.
And the statistics are something like this. 1.7 million new cases of cancer are diagnosed in America every year.
Mm-hmm.
We spend approximately $6 billion a year on cancer research from the government, another $6 billion from philanthropy and other sources. So roughly about $12 billion are dedicated to cancer research.
Yeah.
In 2020, the total cost of taking care of cancer patients would be about $175 billion.
Mm-hmm.
And so far, we have spent something like $250 billion on cancer research since 1971, when war was declared by President Nixon.
Mm-hmm.
So for all of this, we have good things to show that we are curing 68% of cancers that are diagnosed today.
Yeah.
68% are cured. And the 32% who are not cured by the current techniques, their outcome is really no different than it was 50 years ago, because they have presented with advanced disease. So the question is, okay, well, we are curing 2/3 of the patients. Is this something to celebrate? First of all, my question is, we are curing them, but with what?
Right.
The same slash, poison, and burn approach.
Mm-hmm. Mm-hmm.
So that basically, if you think back, What causes cancer? We used to think that there is a genetic predisposition, some environmental exposure like smoking or toxic exposure, etc., or pathogens like papilloma virus, hepatitis virus. But these causes account for roughly 20%. The other 70 to 80% of cancers have no real cause. And the way we have treated this illness historically
Yeah.
began initially with surgery, which can be traced back to actually 500 BC when the Persian queen Atossa noticed a lump in her breast and she tried to hide it, cover it with sheets. It kept growing. So she called her Greek slave who took out his sword and slashed her breast off, and she survived it.
Hmm.
And that is historically, even before cancer was called cancer, a mastectomy was done. Well, we were slashing breasts in 550 BC. We are still slashing them today on women.
Mm.
That's the primary treatment for cancer.
Yeah.
Either surgery or radiation therapy. If patients are not cured with that, then we try to poison the tumor. And these poisons were initially developed in the Great War, which is the First World War, except it was called the Great War because we didn't know we were going to have a second one.
Right.
So in the Great War, nitrogen mustard was developed as a chemical weapon. And when it was dropped it was noted that the victims dramatically reduced their blood counts.
Mm-hmm.
And it occurred to two smart pharmacologists, Goodman and Gilman at Yale, that why don't we use this to poison leukemia cells?
Mm-hmm.
And this is how chemotherapy began. So the first three agents that were developed, Cytoxin, chlorambucil and melphalan, I used with my very own hands on my own husband, Harvey Preisler, who died of cancer. So today we are still using the same things we started using back in the First World War. So slashing, poisoning, and burning with radiation therapy are the way we are curing 68% cases. If you look at overall age-adjusted mortality for cancer, Gil, then you'll be shocked to notice that the numbers in 2020 are finally the same as they were in 1930.
Age-adjusted mortality, meaning we are living longer. So that is adjustment that we are trying to make?
Yes, and not me, but everyone makes that adjustment.
Right.
Traditionally. So the idea is, yes, we have had a 1% decline in mortality every year for the last 27 years. But first of all, it was not because of anything new we developed, but anti-smoking campaign and earlier detection through screening measures. And the second point is that this fall in mortality, which accounts for something like 26% in the last 30 years, really follows the rise in mortality in 60 years ago, and then a fall for the past 30 years, which parallels the rise and fall of smoking.
Yeah.
So basically, to summarize this introductory part, cancer is a disease that's known forever. Mummies have been found with ossified tumors. We started slashing breasts back in 550 BC. We are still doing the same. The only other way we developed to treat it is chemotherapy. And we are still doing the same chemotherapy. So all this effort of hundreds of thousands of investigators, 4 million papers, $250 billion in research, where has it all gone? And why are our patients suffering such draconian side effects?
Right. So I just want to understand at a macro level, Azra. So 2/3 we cure, but we cure with very archaic, let's call it archaic, procedures that have been with us for a long time. And the 1/3 we don't cure, there isn't really any real difference for nearly 100 years in terms of survival. And when you say the age-adjusted mortality hasn't changed either, the whole population, if you take the whole population, cured and not cured population, the total mortality of the population hasn't really changed from an age-adjusted basis. for 70 years?
Well, what I said is that there was a rise in mortality for 30 years and then a fall in mortality for the last 30, which
Ah,
paralleled smoking.
okay, okay.
And I think, yes, so what I'm saying is the age adjusted mortality has finally reached the 1930 level.
Yeah, helped by the fall in smoking fundamentally.
And
Yeah.
screening measures leading to earlier detection so we can remove smaller tumors.
Right, right. And so your passion and real focus is, but by the time we pick it up, by the time we identify an individual has cancer, if it is late, we really don't have a lot we could do. And so the real trick is to figure out how to pick it up as early as possible, in which case we have potentially technology to apply, right?
Yes.
And so is that fundamentally diagnostics that is really need to improve?
Well, here's the truth of the situation.
Yeah,
I have been in this field. I came to this country 43 years ago, trained in medicine and then oncology, and I have been seeing cancer patients all along. From the third week I landed in this country.
yeah.
By 1984, I had started in 77 by treating acute myeloid leukemia. By 1984, it was very clear to me that in my lifetime, the disease is so vicious and complex, there will be no solution for it. And unfortunately, I was right, because you won't people find it hard to believe, but in 1977 I was treating acute myeloid leukemia with a combination of two drugs popularly called 7 and 3,
Yeah.
which is 7 days of one, 3 days of another. And today I'm still doing the same in 2020. It is an embarrassment. It is unconscionable.
Mm.
It is heartbreaking. The number of conversations I have with my patients, the same side effects, same dreadful results over and over. And so it is very clear that cancer is such a complicated disease. It's not a disease of a single gene or a cell or the tissue or the organ or the immune system or the microenvironment or the angiogenic factors. It's a disease of the whole body, essentially.
Yes.
It's a systemic disease, and it's constantly changing, because every time a cancer cell divides, it can make DNA copying errors, which leads to more mutations, which leads to further metabolic and proliferative changes in the characteristics of the cell. So within every cancer, there are thousands of different types of cancer clones present.
Mhm.
And this immense complexity we are trying to approach with a very reductionist conceit of imagining that there'll be one mutation and one abnormal protein, and we'll be able to target it with one magic bullet.
Mhm.
And this kind of approach, or trying to replicate this complexity in lab dishes or in animal models, and then bringing drugs developed in those preclinical testing platforms to the bedside, have resulted in spectacular failures.
Mhm. Mhm.
95% clinical trials fail today. 5% that succeed should have failed, because they prolong survival of a fraction of patients by a few months and cost $100,000 a year.
Yeah.
So,
So let me ask you a question on that as well. So, um, in spite of the life sciences companies and the government spending large amounts of money into R&D, uh, we haven't really made a lot of progress. And is your hypothesis that, I like the term reductionist conceit, is your hypothesis that the processes that we employ to fight an external organism, and it's very well defined, very well potentially very well executed by life sciences companies, but those processes don't really work for cancer drugs? Is that the idea?
Well, the idea is that look at any human disease except infectious diseases. Have we cured diabetes? Of course not. We
Yeah.
try to treat it, but we can't cure it. Have we cured strokes? No, I mean, none of these diseases have been cured. Have we cured any of the autoimmune diseases? So the only thing we can treat is pathogens, but even there in infectious disease, introduction of antibiotics doubled human lifespan.
Hmm. Hmm.
But it wasn't until prevention through vaccination came along
Yeah.
that made the huge difference. So I think we need to realize that for the rest of healthcare, it's going to be the same, not treat disease, but prevent disease. How do we prevent disease? Well, we prevent disease by finding the footsteps, even if it before it becomes the deadly monstrosity. Even the earliest stage should be preventable
Right.
because we boast of cutting and pasting DNA today.
Yeah.
We boast of godlike biotechnology, and yet the treatments we are giving to our cancer patients are Paleolithic. They belong in the Stone Age. So
Yes.
my idea is, look, the only strategy that's worked, and it's not a new idea. Dr. Childe said in 1907 that it's not cancer that's incurable, it's the delay in treatment. So the idea I have is, look, the only strategy that has worked is early detection. Why not? Why are we screening with ancient technology like mammography or putting a tube into someone's colon to look for a cancer? For God's sake, do it once every 5 years. We need to be constantly monitoring the human body as a machine with the latest technology, using thousands of metabolites, analytes, biomarkers, scanning, imaging devices, AI, bring everything to bear, and not to treat end stage disease, but to find the footprints of the earliest perturbations in disease networks.
Right, right. Yeah, so prevention and early diagnostics. So in colonoscopy, for example, I think there are already products available that you can use. It's a test in the stool, I believe. And so what you're suggesting is for cancer. Um, I think you're suggesting two things. Obviously, there might be a whole suite of things around prevention, but after that, early diagnostics and it's almost like you need some sort of continuous diagnostics, right? It's something that could happen at any point in time. So there is no point having a diagnostic in some specified frequency like 1 year. You need something that's constantly monitoring the body. Is that the idea?
Well, listen, let me first of all make a slight correction to what you said. I'm
Yeah.
not talking about prevention of cancer through lifestyle changes, stop smoking, lose weight type of thing.
Yeah.
Because most cancers, as far as we know, the vast majority arise from are random events because DNA copying errors occur.
Yeah.
Cancer incidence increases with age. And the way I think of it is that like a sand pile. If you start dropping a grain of sand at a time, it will make a pile.
Hmm.
But a time will come when one grain of sand will cause the pile to collapse.
Yeah.
Now, this grain of sand was no different than thousands of others that came before it. But why did it cause the avalanche? Because the pile had become unstable.
Hmm.
So my point is, with age, our body has become unstable at many levels. Listen, I look at my face in the mirror and I'm so shocked. I say, this is what's happening on the outside. What's happening inside my body? So all the systems are becoming decrepit.
Yeah.
And basically, because of DNA copying errors, each of our cells that have divided over the last 50, 60 years have accumulated lots of mutations. So the last, one more mutation will cause the pile to collapse because the whole body has become unstable. So the idea is that for prevention, the idea is not that we change our lifestyle and we can prevent cancer, but the idea is that we bring all our technology to bear. For example, I go to sleep in bed sheets that scan me overnight for the presence of a hot area. What does that mean? Anytime a cancer starts, it makes new blood vessels because it has to nourish itself. So the area becomes hot. It can easily be picked up. And now we have this technology that can be sewn into bed sheets.
Yeah.
So let's say a small area, a hot area is detected in the head of my pancreas one night. Does it mean in the morning I should get up and have an open abdominal surgery, Whipple's procedure, and evisceration of every organ in my abdomen? Of course not. It means there's a region of interest in the pancreas. Now, what should be the next step? In the future, the way I imagine it, the next step should be I use a fit loo where part of my urine and stool is automatically removed and examined for 1,000 different variables. And if there is any abnormal biomarker detected, it would be alerted. I stand in a shower that scans me. Then I'm imaged for this region of interest in my pancreas by other means, such as ultrasonography or special tests. And if it turns out that the area is persistent, that it's growing, then it becomes something more of a bigger concern. And a month later, maybe, then I can have blood drawn, saliva, tears, sweat, everything should be examined for the presence of genomic, proteomic, metabolomic, transcriptomic markers that are suggesting that there is something abnormal going on. Right. And the level of technology and the sophistication is such that sensitivity is unbelievable. We can pick out one cancer cell out of 50 billion cells right now. Mm-hmm. The only idea is we have to do it constantly. So, for example, Toshiba just announced, you know this Japanese company, Toshiba?
Yes.
They announced that using literally few drops of blood, they can detect 12 of the deadliest, commonest cancers within 4 hours for $180. Mm. So these kinds of devices, which are using microRNA. Grail is a company that's using cell-free DNA and methylation profiles to not only detect cancer early, they can detect 12 cancers, but also to find the lineage of the organ from which the cancer is coming. So they'll find through what they call liquid biopsy, which means just look in the blood for biomarkers. You find some signature of methylation in cell-free DNA pattern that's abnormal. And depending on the methylation signature, it will tell you whether it's coming from the liver or the pancreas or the ovaries. Once you know that you have a region of interest, you have an area of interest, you can use 20 other MRIs and PET scans and ultrasounds to hone down and find the tumor. But even that is late. What I'm saying is even finding that tumor is late. Mm-hmm. Leroy Hood, who is at Institute of Systems Biology at Seattle, he is been a proponent of this for 10 years and is conducting now a 1 million patient project, which is measuring something like 50,000 analytes from the blood serially on patients. And it leads to, through artificial intelligence, we can keep slicing and dicing till we find the commonly perturbed pathways for various diseases like Alzheimer's or cancer or diabetes that occur years before the actual clinical disease appears. Right. And so the idea is to fixing it there and then is much better. That's the prevention I'm talking about, that by detecting disease earlier doesn't mean when it's just smaller than what we are doing now. No, even before the disease is clinically apparent, we should be able to detect it and prevent it from becoming disease.
Right. And so in the long run, I think what you're suggesting is some sort of a multimodal continuous monitoring. So things that are, designed into bed sheets, into showers, into other things that you use on a daily basis can raise red flags if it finds information that might be useful. But more tactically, I always wondered why can't we have a blood test, for cancer diagnostics? But there is something like that already, right? That is the Cancer Seek product from Johns Hopkins.
I was about to say that Cancer Seek is a brilliant, also in the same genre. They're using genetic mutations in 16 founder genes that have been very commonly associated with cancer, and they are combining it with uh, protein markers of cancer, and then with PET scans.
Yeah.
And using this, they screened, this test is called Cancer Seek.
Mhm.
So using this test, they looked at 10,000 healthy women. They found 26 cancers, 17 were early, and 12 are already cured.
Right, right. And so from an economic perspective, is that something that could be used for a large number of patients, or is it expensive?
I mean, what could be more expensive than chemotherapy, which is
Yeah.
a few weeks of advantage to 30% patients at most? It's unconscionable. These people have brought the whole healthcare system of $3.5 trillion a year.
Mm.
It's costing us to maintain this level of healthcare, which is lagging behind most of European advanced countries, and it's on the verge of a financial collapse. We need something like what I'm talking about, what Lee Hood is talking about, what Bert Vogelstein is talking about. That's early detection and prevention, and get away from these end stage disease treatments.
Yeah, but how far are we, Azra, in terms of applying this for the general population? Would that be part of, sort of the yearly checkup that you do?
First of all, it's not a pie in the sky at all. It's happening now. I gave you all these examples.
Yeah,
You know, they would. One of my favorite books is Thomas Kuhn's Structure of Scientific Revolution.
yeah.
He pointed out back in the 60s that, look, you want the paradigm to change, show the success of your new paradigm.
Hmm.
And once we show the success, it will be like typewriter versus word processor.
Right.
Whoever looks at a typewriter when the word processor comes along. And you know what? Something very interesting. Here's a saying: if I asked my customers what they want, they would have said a faster horse. You know who said that? Henry Ford. You have to be imaginative and you have to do radically different things when the paradigm has failed for half a century. This paradigm has completely failed. The current cancer efforts are largely wasteful and hurtful to patients.
Right.
They need to stop, but we must show a new paradigm. To do that, you asked me how long will it take, and economic issues. Economic, I already answered. It's going to save us billions, if not trillions of dollars by preventing disease. And it will help patients not be undergoing transplants and CAR T therapies. My God, whole industries arise just to control side effects of them.
Yeah.
So that's the economic side. And on the timeline, my God, it's already happening. And what's happening is continuous monitoring of the body. We are working, for example, I'm working with biomedical engineer Samuel Sia at Columbia University, and his device called M-Chip
Mhm.
is already FDA approved for testing PSA sitting at home. You can simply prick your finger, drop one drop of blood onto the chip and put it in the device that comes with it, and you can read your PSA level at home. You can so I'm saying, as we find biomarkers like PSAs for prostate cancer, when we find a marker for ovarian cancer, for lung cancer, for liver cancer, we make a protein like a barcode on the M chip. And with one drop of blood, as Toshiba showed, you can find all these sitting at home. You can do this once a week on yourself.
Yeah.
And these are, so how far away are they? My God, the Smart Bra and the Fit Loo are already in clinical trials at the Canary Center for Early Detection of Cancer at Stanford.
Hmm.
Most of these things are happening, and mark my words, Gil, the decade of 2020 to 2030 will see a complete reversal in healthcare, moving away from disease treatment and towards prevention. And all of the sophisticated technology we have developed, it just is now being brought to bear on the bedside.
Yeah, yeah. So if your dreams come true, then Azra, this would become more like blood pressure or H1AC measurements. So, things that we routinely do in primary care, these things could be at that level, right? You're routinely
No,
checking
they'll be at the level of Fitbit.
Fitbit. Yeah,
Things like that. You're just wearing a necklace, we're wearing a wristband, and it's recording everything going on in your body. Like I said, the smart bra is a bra that women have to wear just for 2 hours a week. And this bra is fitted with 200 tactile sensors that can detect changes in temperature and pressure, etc., and is very accurate. And forget about having one mammogram a year.
right, right. And so this is really the theme of your book too, right? So let's talk about your book a little bit. So I think you're already laid out, what the path might be. There are really good signs in terms of diagnostics that we see, early diagnostics. That appears to be the path, right? That is where the leverage is. Once somebody has it and has it for a period of time, we don't seem to have very good interventions, neither from a therapeutic perspective nor from a surgical perspective. And so, what you're arguing is, let's not make that happen. Let's, if when it happens, let's pick it up very early. Do you want to talk a little bit about, what the book's conclusions are, and if you look forward next 5 years, where we might be?
Good question, Gil. First of all, I'm a big reader of Dorothy Parker.
Uh-huh.
And one of the things she said is that, look, the second biggest favor you can do to your friends if they tell you they're writing a book is the second biggest favor is to give them a copy of Strunk and White's Elements of Style. But
Uh-huh.
of course, the first is to kill them now when they're happy. So I wasn't into writing books at all. I'm not a writer or author. In fact, I'm a very busy oncologist and I supervise a basic research lab.
Yeah.
But my third bit of credential is that I am a cancer widow.
Yeah.
And my husband developed a second cancer. He was diagnosed with his first cancer at 34 years of age. He was cured of it eventually. But then at 57, when our daughter was 4 years old, he got his second cancer, completely unrelated, a totally different type of cancer.
Mhm.
And by the way, that brings me, before I go on, to another point that I don't want to scare your listeners or audience, and many of us have had cancer already. And if we haven't, then our chances are 1 in 2 if we are male and 1 in 3 if we are women. So it's not something happening to others, but 1 in 5 new cancers occur in a cancer survivor.
Hmm.
And Harvey, my late husband, is the perfect example because the second cancer just killed him. So if it's 1 in 5 new cancers occur in a cancer survivor, just do the math. If we have 1.7 million new cases a year, that means we have 300,000 of those cancer cases occurring in survivors.
Right.
There are 15 million cancer survivors in America today. Those are the people at high risk of getting another cancer. They are the ones we should be screening aggressively for early detection of the first cell. Don't you think? Because we can save their lives.
Right, right. And that is not happening now as part of the
No,
standard.
no,
Okay.
not happening now. I think there has to be, it's got to be like, literally, we have to have almost the competition of the space age, but the cooperation of the human genome sequencing age.
Yeah.
And then, of course, the far sight of having a prevention and vaccination program. So you asked me a bit about the book and what I suggest will be happening in the next 5 years. And I was telling you that my credentials are that of an oncologist, a scientist, a cancer widow, and none of those things had still compelled me to write a book.
Yeah.
My disappointments, my crushing disappointments over the last 40 years, seeing cycles of excitement and then terrible descents into failures when we bring those exciting findings to the bedside, have even those hadn't forced me to do it. What happened finally was that I was faced with my daughter's best friend, not her boyfriend, her best friend, Andrew, who was gay.
Hmm.
who has been in and out of my house since he was 15 years old. And when he's 22 years old, he returns from Paris after finishing a course in fashion design, comes back to begin his life, and suddenly feels weakness in his arm. And next thing you know, he's quadriplegic. And they found glioblastoma multiforme, one of the deadliest brain tumors known to man, a 9 centimeter tumor in his brain.
That's what Senator McCain had too.
That's what Senator McCain
Yeah,
had.
yeah.
And so they could only remove, the neurosurgeons could remove only 90% of the tumor. And from that moment on, Gil, all of Andrew's treating oncologists knew that his chances of survival are basically 0.00, beyond, whatever the whatever the time it will take for the tumor to kill him. And yet what followed was extensive surgeries, round upon round of chemo, radiation, immune therapy, more chemo, this poor boy, when he was told his diagnosis, he just turned to his mother and he said, "Mom, don't worry, just call Azra. She's on the cutting edge. She will cure me." And it is this, the viciousness of his tumor on the one hand, and the utter helplessness of all of us to do anything to help, that slapped me physically in my face.
Yeah, yeah.
How are we failing the Andrews of this world so badly? How is it possible that, and you know how many times my own daughter, they were both 22.
Yeah.
23 he dies. She calls me how many times from his bedside, "Mommy, I heard you and Dad were helping cancer patients. You're not helping Andrew." And that's why I wrote this book, that we can't let this continue while we are, trying to untangle the webs of cancer with our fingers. For God's sake, it will take us hundreds of years to understand the disease, but in the meantime, too many Andrews are dying. How do we save them? By early detection.
Right.
Now, who could have ever imagined a 22-year-old who has pain in his arm has a 9 centimeter tumor sitting in his brain? No one, which means that cancer is a silent killer and that no age is immune from it.
Right.
Which means we need to monitor the human body from birth to death. And that's why I'm working on implantable devices.
Yeah.
That can detect rare cancer cells circulating in the blood very early. And even earlier than that, we'll be able to prevent the disease. And I'm not the only one. I mean, this implantable devices and things are being worked on with great vigor, but the only problem is that all our institutional grants, 95% of them are going towards fighting end-stage disease and only 5% towards early detection. So this is what forced me to write the book. Bring the patient, stop congratulating yourself on the wonderful things you've done in the war on cancer. You haven't. You're still using slash, poison, and burn. So don't go around prancing on stages in national meetings and scratching each other's backs and giving each other gold medals and all this phony talk. It really upset me, because I want to bring the patient back front and center into every conversation about cancer. So the book I wrote, Gil, is not about cancer, it's about cancer patients.
Yeah.
It is full of stories rather than statistics. But then I tell the story of cancer also all along. And the conclusion over and over is the same.
Right.
End-stage cancer, we haven't budged the cancer at all once it's advanced. So the answer is find it as early as possible and let us apply more money to do that.
I'm glad, Azra, that you have taken up this fight. It sounds to me that it's a true resource allocation problem. Both the grant providers at the societal level, but also within life sciences companies that tend to be somewhat tactical, right? So incremental therapies is the course of the day, and that is how they think about new drugs. What you're suggesting is that these incremental things that we do in the area of cancer adds almost no value to the human at the end of that chain. It might be a few days, few weeks, and during that process, it imparts a high amount of pain to that individual. And so what you're suggesting, I think, Ezra, is that we have to really throw out the processes that we deployed in the area of oncology and almost start over, right?
Well, I am basically saying that, but the fact is that it's not even that systematic. It is all so haphazard.
Yeah.
And one of my biggest complaints is the very institutions like FDA, who are supposed to protect patient interests, have given in to pressure from patients' advocacy groups and families and societies. Where are the new drugs? Where are the new drugs? You know that FDA has lowered its bar of approval of drugs first to 2.5 months for a fraction of patients. So out of 100, if 25-30% patients show a benefit for just for 2.5 months median, which means only 15% will go beyond 2.5 months. They were approving these therapies for the cost of 100 to 200,000 a year, but now they don't even use survival as an endpoint. They just use progression-free survival, which is unconscionable. So the very institutions who are supposed to protect the patient interests are squandering it. As a result, 42% patients in this country diagnosed with cancer, 42% become completely financially ruined by 2 years.
Yeah.
Why?
Yeah.
Why is that happening? Because we keep giving them one failing therapy after another. It's not bad enough they're dying of cancer. First, we have to fleece them of every penny they have saved and make them impoverished.
Yeah, I know that you were involved with Vice President Biden's Cancer Moonshot initiative. How is that going? Is that putting a new focus on these ideas?
No, I'm afraid not. A very small amount in that initiative has gone to prevention. Most of it is again because you see who runs the whole show? It's the same people whose labs have been doing this work, and they divide up every money that comes along. That's why I'm saying no one is going to willingly give up what they're doing.
Yeah. Yeah.
But once we show a new way, then they'll become irrelevant. That's my point. So I don't care what they do. My point is, let's really take off the blinders. You know what Einstein said? If you give me 1 hour to solve a problem, I will spend 55 minutes thinking about the problem, 5 minutes to solve it.
Right.
So we are not even ready to see the problem right now. We have each one of us has painted ourselves into a silo, and that's all we look at with a tunnel vision. Just look at oncologists like me. I mean, let me criticize myself. I cannot make decisions on my patients. Why? Because it is more in the interest of economic interest, etc., to have uniformly treated patients. So the system that has evolved in this country is a group of key opinion leaders, KOLs,
Yeah.
will get together and decide that they will review the field of cancer treatments, which is not very great, especially for end stage pancreatic cancer. But then they'll decide, okay, these 4 drugs will be first line of treatment, these 3 will be second line, and these will be third line. I have to give those. If I don't, then I'm opening myself to legal challenges. So as a result, even though I know this will ruin the patient financially, and 80% chances that they will never respond even for a day, and 20% chances they'll respond for 2 months, yet they will be financially ruined. I shouldn't give it, but I have to give it
Right.
because
Yeah.
I'm
It's
going to go
it's
to jail.
yeah. It's interesting, as right now. We have been talking about personalized medicine for 25 years, 30 years. I don't believe life sciences companies have a great interest in that, but it really started to become more interesting in the provider arena, and oncology is probably the most applicable area for personalized medicine because, as you have said, everybody's cancer is different, every organ is different, they mutate on a very regular basis, so the progression of cancer for an individual is different from another, and it's really something that is screaming for personalized medicine. But it sounds like we are applying the standard care defined in packages, just like any other disease state, right?
Right, but I think it's all changing. This in the coming 10 years, I think each of us individuals will be surrounded by clouds of billions of data points that will be constantly monitored and analyzed and then rendered into algorithms that we can follow very easily, taking into account our specific microbiome, our specific eating habits and exercising habits, and then disease perturbed networks,
Yeah.
and our genetic inherited DNA that we were born with. All of this is coming together, and it's going to change healthcare completely, and it's happening, and I'm excited about it.
Yeah, that is good news. Hopefully, we can continue on this track. I mean, the good news is that there are a lot of technologies. They didn't really start in healthcare; it started in other domains. But we can actually take them and apply this in healthcare in much more systematic way. So hopefully, all of that is going to help. And your focus in terms of continuous monitoring of the human body. So, really, that the home itself becoming a way to monitor, what is happening inside the human body. I think there are technologies there too that is coming together. So hopefully we'll figure it out in the next few years.
I'm very hopeful.
This has been great, Azra. Thanks so much for your time. Really appreciate the time that you spent with me, and good luck with all your research and with all your patients.
It's been a pleasure and an honor to be with you. Thank you, Gil.
Thanks so much. Bye.
Bye.